Sorry, it was a ring on my mobile phone, so we continue. I had stopped on the prediction of the place of the earthquake, and you see, I understood that my method gave a possibility to predict the place, even the place of future seismic catastrophe, using the data strictly before the earthquake. But it was done, unfortunately, it was done only after the earthquake. It was not published before earthquake, and so this is a retrospective prediction of the place. And you see, this is the map. This is the map of so-called the same value which I show you, the singularity support width, singularity spectral support width. And you see this blue domain. Blue domain is the domain where the value of delta alpha, the value of singularity support width, it has low values with respect to all other. And you see, this is on this slide, on this panel. And on this panel, you can see the distribution of aftershocks of the Great Japan earthquake. And you see the distribution of, this is taken from Japanese site, which is devoted to the problems of the Japan earthquake. And you see that this cloud of aftershock almost perfectly coincides with the domain of low delta alpha values, low values of singularity spectral support widths. So we can predict the place. We can predict the place. We can predict the place. Automatically switch off when I spoke on mobile, and so we can even predict the place. And you see, this map was built on the data from the beginning of '97 up to the end of February of 011. Yes, but you remember that there was a point inside this seismic history, the earthquake in Hokkaido. Okay, let's see what will be these pictures if we split the history of seismic history, history of observation on Japan islands into two parts. They are approximately equal parts. The part from the beginning of observation till the moment of Hokkaido earthquake, and then from beginning of 04 till the end of February of 11. And you see, on the first part we see that the domain of low values extract the same as for all data. The region which was covered by aftershocks of Japanese earthquake. Why? It's quite natural. It's quite natural because such mega earthquake was prepared maybe for 30 years, and so the beginning of this observation was 1997, and that means that even starting from the very beginning of this observation, this method of processing the data could extract where it will be the future earthquake. But if we take the region which is most close to the time interval which is the most close to the earthquake, from the beginning of 04 till the February of 11, you see the region of low values with very high precision extract the hypocenter of the next of the mega earthquake. You see, this is big star is the hypocenter of the earthquake. And so this is all about my presentation, but I can show you one more interesting picture, which is not included in this brief presentation, but which is included in the detailed presentation. What is going after the earthquake? After the earthquake, you see these curves. These were mean values of estimates after earthquake, before and after earthquake. Can you see this? Outliers, variations of the parameters of microseismic field after earthquake, till including 2 months after earthquake, because already we have 2 months passed from earthquake. You see delta alpha, which was low, it was mean value was high, then became slightly low, and then after earthquake it became very high. This is an index of predictability. You see it was low, then because rather high. Or if you remember, I spoke that the waveform became highly predictable. And what is after earthquake? It was a sharp down. So this is a logarithm of variance, and this is another. I will not speak because it needs much more time to explain what means this. What means this? I just can main detail that this is index of smoothness of noisy waveforms. More is this index, more smooth are waveforms. And you see that when you approach into great earthquake, the waveforms became more smooth. They became more smooth, and just after the earthquake they became less smooth again. So this is the main details, the main results of my method of prediction, which is based on multidimensional processing. Time series, which are recorded simultaneously on the seismic, not only seismic, but you can use any other observation on the points of observation of the network which cover the seismically active region. All details are described in our project. How it is possible to analyze this data, which earthquake of which strengths could be predicted, and so on, using this data. But so you see, this is not simply some consideration which could be used or could not be used for earthquake prediction. This is a tool which really works. Using this tool, I have predicted Great Japan earthquake. Thank you.